Hi Greenhills Bio, we're back looking at lipids. So we're in the biomodeling on the second page, about 3/4 of the way down the page, on the biomodeling, which is this assignment here. So we're on page 2, and we're right down here where it says go back to the index frame and click on fatty acids. Here we are, we're going to click on fatty acids. And it says fatty acids are one of the 2 building blocks of lipids. What is the other building block? This is from your course pack, and you should be able to find it. If you can't find it, then look in your textbook. Look in the course pack that is online on Greenhouse. All right, you've also learned that fatty acids can either be saturated or unsaturated in both a hydrocarbon chain. In both, a hydrocarbon chain attaches to a carboxyl group. So we're going to look at the fatty acids here. Palmitic acid is the first one we're going to look at, so we'll click here on palmitic acid. And it says, it asks how many carbons does it have in its hydrocarbon chain. Remember that each carbon is where we see a bend or a junction in the chain. So we're counting these ones. But remember that each fatty acid has an end that is a carboxyl group, the COOH, which is, I don't know if it's going to show us the double bonds here. No, it's not. But there's a double bond to this oxygen here and a single bond to this oxygen and OH. So this carbon here isn't actually included in the hydrocarbon chain. So you want to be counting up and seeing how many bends in this, or little changes of direction do we have? How many carbon atoms? That's a carbon atom, that's a carbon atom. So count them up, see how many we've got. Then we're going to click and ask to look at the end view of palmitic acid. And the question asks how you would describe the shape of this molecule. So looking at it, what does this molecule look like? There's the end view. We've got our carboxyl group here at the end, but notice that we can look straight down the molecule. So just have a look at that. All right, the next thing we're going to do is we're going to flip over the page, and it asks us to go back to the index, or actually we don't have to go back to the index. We can just click on oleic acid, which is the next fatty acid that's here. And we're going to look at this structure, and it asks us again how many carbon atoms are in the hydrocarbon chain. So remember, this one doesn't count. We're going to ask it to show the double bond, and it's going to show all the double bonds as sticks, so that's why we see that this is actually a double bond to oxygen. So we're not going to count this carbon here, but you do want to count all the rest of these carbons here. I'm going to uncolor this one. And then I'll move it this way. Here's, you can see the double bond there. It's right there. All right, and then we want to be counting all of these carbons. So we're counting these carbons, and then we're going to count the carbons in this part here. So you want to come up with a total number of carbons in this molecule. There's a good view where you can kind of see them all. So put your answer down as far as how many are in the hydrocarbon chain. The next question it asks is how many double bonds are present in this chain. Well, I hope that you can see that. Right now, again, we're looking at the chain. We're not looking at the carboxyl group. All right, then it says study the molecule, and then as specifically as you can. We're looking at oleic acid now. This is the one we're looking at, and it says describe the shape of the hydrocarbon chain. So you have to describe what shape is this. It's up to you to come up with a shape for it, but describe it as best you can. All right, next we're going to be looking at linoleic acid. It has 18 carbon atoms total and 2 double bonds. It tells us right there. So we'll look at linoleic acid. Here it is. So again, the first, I'm going to show the double bonds as sticks. There they are. So then your assignment asks you to study the molecule, put down how many carbons are in its hydrocarbon chain. Well, you can count those out. Try and rotate it slowly here for you. I'm not doing a very good job of that. you go. All right, and then it asks you how many double bonds are present between carbons in this chain. So put those down. This is the first linoleic acid. All right, and then you need to describe this shape. Part C asks you to look at linoleic acid again. So it's a different form of linoleic acid, still 18 carbon atoms in the hydrocarbon chain, but it's got 3 double bonds. So we're going to look at the double bonds here. We'll show them as sticks, and you can see, and I'll even color them so you can see them. Here they are. So you need to count up how many carbons are in the hydrocarbon chain. Again, not including the carboxyl carbon. And then describe this shape as well. How many double bonds, and describe the shape. And then part D asks you, as the number of double bonds increases, how does the shape of the hydrocarbon chain change? So you need to go and look at that and kind of look at all your answers and come up with an answer for that question. We're going to go back to the index and look at triglycerols, another name for triglycerides. Let's take a look, and we're looking at, here is the molecule, and it says to look at 1 palmityl, 2 oleal, and 3 steryl glycerol. That's the name of this whole thing. So let's take a look at it. And you're going to look at the visual number of oxygens compared to the number of carbon and hydrogen. So we can see that the oxygens are in red. All right. You don't need to count up the actual numbers, but what can you tell about the ratio, or how you can tell that this is obviously not a carbohydrate molecule? And I just gave you a clue by accident, so I hope you use it. How do you know that's not a carbohydrate? Next, we're going to click on this X here and see what it's formed by. It is formed by glycerol, which is this nice bright green, this palmitic acid. Hey, did we just look at palmitic acid? Yes, we did. And then it's got a molecule, and then it's got a stearic or oleic acid here in this kind of brownish color, and then the red is stearic acid. Now let's look at the double bonds. Always good to look at the double bonds. And what do we see? Oh, look at that. We can look at palmitic from the end. We can look at stearic from the end, and then we can try and look at oleic from the end, but we can't look at it from the end. And hopefully at this point you can tell why. What does the oleic, the one in the middle, have that the ones on the side don't have? All right. So it says which of the fatty acids are saturated and which are unsaturated. Hopefully you can tell, and then you need to explain how you can tell. All right, that's the end of the lipids section, so I will post another link that will take you through the protein section.